everyone, my name is Kajal and today I'm answering the question, can you enter the field of robotics engineering from other engineering disciplines? In today's video, I'll talk about 6 different subfields within robotics engineering and talk about which fields are good if you're coming from a background of mechanical, electronics, mechatronics, or computer science. I've included all of the timings here and in the description below. And this is your gentle reminder to hit the bell notification when you hit subscribe so you're notified every time I come up with a new video. So without further ado, let's get into it. Number 1, designing a robot. Given a task, you need to decide what type of a robot are you going to use. You need to think about, is it going to be a wheeled or a legged robot? If you're going for wheeled, are you going to go for a differential drive, tricycle, or a 4-wheeled robot? Essentially, you'll be deciding on the actuators and sensors to use to build your robot so that it solves the problem at hand. Now remember, you also want to build a robot that is lightweight, efficient, and cheap. You're also going to have to think about the battery. How long will the robot run and how much weight it will add to your actual robot. This field has a higher focus on mechanics and electronics, and that is why it's also often known as mechatronics. The second subfield is robot modeling. Now that you've decided on your actuators and sensors and built a robot, you actually need to create a transformation tree on how these different things are connected. How is your robot's body connected to each of the wheels or sensors that you've added to your robot? This involves thinking about forward kinematics, inward kinematics, Jacobian, and creating a transformation matrix. While it might seem like you'll be working with the mechanical parts, you'll also be working with software like SolidWorks to create CAD models. These are great for creating proof of concept and figuring out the sensor coverage. This aspect of robotics has a higher focus on mechanical engineering and a bit of your imagination. Trust me, you'll be playing around with your fingers to figure out the Jacobian. The next subfield is controls. The simplest use case of control is ensuring the robot drives straight. You use controls to adjust the robot trajectory due to wheel slippage, actuators, or even sensor errors. Another controls project you might have heard of is an inverted pendulum, keeping it upright using a combination of a cart and a PID controller. This should tell you that controls is about a combination of mechanics and software engineering. You need to design a system of actuators and sensors to create a feedback loop, and you need a code to send in the control trajectory. Our next subfield is the popular computer vision and image processing subfield. Cameras are becoming more and more popular as a sensor choice. Image processing is about extracting useful information from the data you received from your cameras. Maybe you're looking for a specific object or you're using this information to create a map around you so the robot knows where it can drive. This aspect of robotic engineering is more focused on software engineering. You need to know how to code and you need to know a few algorithms to be able to do computer vision. Our next subfield in robotics engineering is perception. Cameras are not the only sensors a robot uses. You also have light and sound-based sensors such as time-of-flight cameras, lidars, and sonars. You also have haptic sensors for a sense of touch. Working with all these sensors comes under the umbrella of perception. Your goal here is to understand the world around the robot to make decisions such as where the robot can drive or where the robot can pick or place an object. So in that sense, image processing and computer vision does come under the umbrella of perception. Again, this aspect of robotics engineering is more focused towards software engineering. Our next subfield in robotics engineering is navigation and path planning. This subfield comprises of localization, mapping, and path planning. Localization is about identifying where your robot is, and mapping is about creating a map of the environment around the robot. In this sense, mapping is a combination of perception and navigation. Now, localization and mapping can be done separately or they can be done together, which is called SLAM. Simultaneous localization and mapping. Next, path planning is about creating the path for the robot to go from point A to point B, versus motion planning is about how the robot will actually drive from point A to point B. Motion planning is more about computing the actual motor commands for the robot to drive. And the same applies for manipulators. How will the robot go from point A to point B and how the different joints will rotate to achieve this second location. Generally, people specialize in either mobile robots or manipulators when it comes to path planning. Again, this area of robotics engineering is more focused on software engineering, where you need to know how to code and you need to know few algorithms. So depending on your area of interest, you can enter robotics engineering through a background in mechanics, electronics, mechatronics, or computer science. If you're someone who's looking to enter the field of robotics engineering, you might enjoy this other video from my channel where I talk about beginner robotic projects. Before you go, if you enjoyed this video, make sure to give it a like, and if you haven't already, don't forget to subscribe. Also, tell me about your aspiration in the field of robotics in the comments below. Thank you for watching, and I'll see you in the next video.